So, hello. Today we will study the topic of mathematical physics, complex variable, and a complex number. So, before starting, the most basic book for complex variable or complex numbers is Afkin and Riley Hobson. Yes. So, these are the most common books which one should study for the basic knowledge, and if you want to learn to advanced level, you can go for Sadri Hassani. Okay. Complex variable. The most basic thing we know of complex variable is we write it in the form z is equal to x plus iy. Okay, where x and y are some variable, it can be anything, any number, and I is an imaginary number. Okay, and this whole thing is a complex variable. And if we replace x and y with a and b, okay, where a and b are some constant, then it will be called as a complex number, not complex variable. Okay, the form in which we write it, like the form where z is equal to x plus iy is written, is the Cartesian form. Okay, or Cartesian notation we can call it. In simple language, if we represent this complex number on xy plane, so we may say this is x coordinate, this is y coordinate, and it is the z point. Okay, so what is a complex variable? A complex variable represents a point on xy plane. If this is an xy plane, then this z is basically a complex variable. Okay, and the distance between the origin and this z is signified by or denoted by modulus of z, and the angle is it creates as theta. Okay, so yeah, it is as I mentioned, here is r is equal to modulus of z. So it is the Cartesian notation that we mentioned. Now we move forward from Cartesian notation to the polar form. So we write z is equal to r cos theta plus I sin theta. Okay, and in other term we can write it as cos theta plus I theta can be written as e raised to power iota theta. This is the polar form of a complex variable. Now, how this polar form came, like ये polar form कैसे आई है? So we have heard of, like you must have heard of the Taylor expansion. Through Taylor expansion, we get this important outcome which one must remember. Cos theta plus iota sin theta is equal to e raised to power iota theta, and cos theta minus iota sin theta is equal to e raised to power minus iota theta. Thus, the first one, cos theta plus iota sin theta, is equal to e raised to power iota theta, is also known as Euler's formula. Okay. Now we move forward into complex number or into complex variable. One of the most common thing is iota. Like it is the base, it is the formation which is making it a complex number. Otherwise, it will be a real number. Okay. So what we know of it is iota is equal to under root minus 1. Okay. Iota square is minus 1. Okay. Iota cube is minus of iota. Okay, and iota raised to power 4 is 1, and it continues the same pattern. Okay, like I raised to power 5, I raised to power 6, I raised to power 7, I raised to power 8, it follows the same pattern. Now we know that, like we are using the above notation over here. Like here it is written z is equal to r e raised to power iota theta. Okay, we will be using this iota theta here. Now we write e raised to power iota pi by 2. Okay, so now e raised to power iota pi by 2, using Euler's formula we write it as cos pi by 2 plus iota sin pi by 2. Okay, we know cos pi by 2 is 0 and sin pi by 2 is 1. Therefore e raised to power pi by 2 can be called as iota. So the other value of iota is e raised to power iota pi by 2. Similarly, if we use pi at the place of pi by 2, we get cos pi plus iota sin pi, which is equal to -1. Okay, so what is the other value that we get here is e raised to power iota pi is -1. Okay, we move ahead. Now these were a few basic values of iota and some quantities which we derive from the value of iota. Okay, now when we talk about ln, that is natural logarithm, we generally see that for ln x we consider the value of x greater than 0 for real domain. But when it comes to complex variables, when it comes to the domain of complex number, it is free of the sign of x, like it can be positive, it can be negative. For example, like in complex domain we accept the negative values also. For example, we have written here ln -2. Okay, that is natural logarithm of -2. What we can write it as ln 2 into e raised to power iota pi. Now how iota pi? Because we know -1 can be written as e raised to power iota pi, correct? So similarly we write here 2 into e raised to power iota pi, correct? And on further solving it, we can say, I will tell you about this later on. Now if we use, instead of using pi by 2 and pi, if we go for 2 pi, what we get is cos 2 pi plus iota sin 2 pi. Okay, and what is its value? Its value will be 1. Another conclusion we get here is e raised to power iota 2 pi will be equal to 1, and we take the general case for it, e raised to power iota 2n pi. Okay, where n can be 0, plus 1, minus 1, plus 2, minus 2, it can be any number, it is 1. Okay, so as above we have written ln -2 is equal to ln 2 into e raised to power iota pi. Okay, we can further expand it as ln 2 into e raised to power iota pi into e raised to power 2n pi iota, like iota 2n pi. How has it came here? We simply saw just now that e raised to power iota 2n pi is equal to 1. Okay, so whatever was written here, it can be multiplied by 1, right? It can be written as into 1. So we simply change that 1 into the form of iotas. Okay, so what we get of it as ln 2 plus iota 2n plus 1 pi. This is the expansion of ln -2 with the help of complex numbers. Okay, what we see from it is this ln is a multi-valued function. How it can be a multi-valued function? Because it is dependent somewhere on this n. The n has multiple values, the argument thing will have multiple values, and when it has multiple values, it means it will give you different values. Okay, so yeah, ln is a multi-valued function. After the natural logarithm thing, here's something important. Now iota raised to power iota, so we know iota is equal to e raised to power iota pi by 2. Okay, we write it as e raised to power iota pi by 2 raised to power iota. Okay, and as the power gets multiplied, iota square is -1, hence iota raised to power iota gives out e raised to power minus pi by 2, and here we get is iota raised to power iota is a real number, means a complex number, power of a complex number like iota raised to power iota is not an imaginary number, it is a real number. The complex number may also lead to an the complex number may also lead to a real number too, and it is the example of it. Like it comes in the question paper too, like what is the value of iota raised to power iota? Its value is e raised to power minus pi by 2. Okay, another important question which previously came into for the exams was iota raised to power iota raised to power iota, means there are 3 iotas raised to in power of each other. So the most common thing which we need to understand is we never start from the base. Okay, we need to move from top to bottom. That is the direction of calculation we prefer. Okay, so iota raised to power iota, we know e raised to power minus pi by 2, hence what we get is we solve these two and I raised to power e raised to power minus pi by 2. Okay, and we know iota is e raised to power minus pi by 2 again, e raised to power means iota is equal to e raised to power iota pi by 2. Okay, so we use the same notation again, and on further solving it we get iota raised to power iota reads out cos pi by 2 e raised to power minus pi by 2 plus iota sin pi by 2 e raised to power minus pi by 2, which is a complex number. So what earlier we saw was iota raised to power iota gives out a real number, and iota raised to power iota gives out a complex number. So what we get is it is a complex number. Okay, here's another example. This question is 4 raised to power 4 raised to power 4. People might have different answers for this particular question, but the exact answer is first we do this thing, the upper part, then the lower part. So 4 raised to power 4 is 256, hence the answer will be 4 raised to power 256, not 256 raised to power 4. Never. This is the way we proceed into the steps. Now we again talk about the complex variable in a more graphical way. Z is equal to x plus iota y, it is a Cartesian notation. Z is equal to r plus iota theta, that is a polar notation. The complex variable behaves like a vector on a complex plane. It is something pretty important for us to know that complex variable acts as a vector on a complex plane. So whenever we talk about further calculations and all type of things, we prefer using it as vectors, which help us solve the problems easily. Yes. So here we can see in xy plot or xy graph, here is a vector z2, here is a vector z1, which are basically two complex numbers, their mode, and the third one is like z1 minus z2 whole modulus. Okay, there is these lines which act as a vector, and these are the complex variables or complex number. Okay, in earlier classes like class 9th and 10th, we must have heard about the inequalities of triangle or the properties of triangle. that sum of two sides of triangle is always greater than the third one, and difference of two sides of a triangle is always less than the third side. Okay, that is the identity which we will be using here for the complex numbers and so on. So z1 mod plus z2 mod is always greater than z1 minus z2 whole mod, which is from this particular plot, and also z1 minus z2 whole mod is always less than z1 minus z2, or yeah, we can say that. Now z is equal to x plus iy. Here we can see a different plot. It is z1, it is z2. The third vector will be using the law of triangle of vectors. We get it as z1 plus z2 whole mod. Okay, so for this particular figure we can say z1 plus z2 individually mod is greater than the overall mod of z1 plus z2, and we can take this theorem for n number of vectors. For example, there are n vectors z1, z2, z3, z4, z5, z6 and zn. So we can say that their overall sum with a modulus around it is always less than their individual modulus addition. Okay, and this is the particular concept which we will be using for Darboux inequality later on. Okay, and there's one important thing about z we should know. Z basically modulus of z, that modulus of z is defined as under root x square plus y square. It's the one of the most common thing which we all know. This modulus of z is the distance of the particular variable, particular point from the origin. Okay, and mod z square is equal to x square plus y square. It's the basic thing which we all know. Z is equal to x plus iota y, where x is the real part of z and y is the imaginary part of z. We must know that iota is not the imaginary, iota is not under the imaginary part. Like when we talk about y and the number written is 4x plus iota 3, so y will be 3 only, not 3 iota. Okay, and for polar form we can write as z is equal to r e raised to power iota theta, where r is under root x square plus y square and theta is tan inverse y by x. This theta is basically called as argument of z, and there is one important property about argument of z, that it is not uniquely defined or uniquely defined. It means, for example, z is equal to r iota theta. Okay, we can write it as r e raised to power iota theta into 1, and 1 can be written as e raised to power iota 2n pi, yeah, n2 pi or whatever you call it. Hence r into e raised to power iota theta plus 2n pi. Here this particular thing shows that it is not uniquely defined. Like there can be various value of n giving out the same thing, but it is not uniquely defined. And to make this argument unique, we introduce the concept of the principal argument. Now we talk about some basic equality of complex numbers. Like for example, there are two complex numbers which are equal, z1 and z2, then their real part should be equal as well as the imaginary part should be equal. Okay, and modulus of z1 and z2, like modulus of z1 into z2 is modulus of z1 into modulus of z2. Modulus of z1 by z2 is equal to modulus of z1 by modulus of z2, and modulus of z square is written as modulus of z whole square, as in for any number raised to power n, and if we take out the modulus of it, either we take an inside or we take an outside, it has no effect onto the number. Okay, now here is a common question, that is calculate the minimum and maximum value of modulus of z raised to power 4 plus 3z square plus 2 if z mod z is equal to 2. So we expand it, factorize it, create it into or take out into this form. What generally we people do is put out the value of n and we get it as mod 30, but we all should know it is like by chance. Like in most of the cases it will not happen that you directly get the answer just by putting out the values. What we need to do, what is exactly the method, is to go for the inequalities. Okay, so here it is written mod of z square plus 2 mod of z square plus 1. Now as per the inequality, mod of z square plus 2 will always be less than mod of z square plus 2, and similarly mod of z square plus 1 will always be less than mod of z square plus mod of 1. We add both those equation and write it as this. Okay, on further solving it we put out the values and hence we get the maximum value of this expression is 30. Okay, similarly we take out the identity for the negative one. Z square plus 2 is always greater than mod z square minus mod 2, and similarly z square minus 1 is always greater than z square mod minus 1 mod. So when we solve this identity, what we get on for the calculation is 6. Hence the minimum value of the function is 6 and the maximum value of the function is 30. Okay, it's not like through this method we got plus 30 and we take out as minus 30. No, that is not the way. We need to use inequality to find the correct answer. Now another thing is that why do we need to study complex number? See, in normal life we don't use it. Like in normal life, for example, if you're purchasing apple, you don't ask for the complex number thing. Okay, I give you this amount of thing, this much money, this much complex number, this much this. No, that's not the case. But when it move forwards toward the branch of physics, we need complex number. The most common example is to explain the decay of electromagnetic wave inside a conductor, we use complex dielectric constant. For example, here is a metal, here is a light wave entering. When we define its dielectric constant, we take it as iota epsilon plus minus. Okay, this iota is the complex number, like makes it a complex number. For advanced physics we need it. For example, quantum mechanics, for solving any of the wave function we take the complex part too, and a wave function without a complex part shows no propagation. Like for any of the psi which is real, then it shows no propagation. It need to have that imaginary part for the propagation thing. And if we talk about the spin angular moment of electron, then too we define it using the complex numbers. And for Fourier transform we need complex numbers, and use of complex number basically help us solve equations quite easily. Okay, here is an example mentioned, you can see it all, and thank you.